there. As you probably know, I am Chris from Airwindows. This is going to be another plug-in coding day. However, I'm getting ready to have it. It looks like my fire has completely gone out, so I need to remedy that. So that'll take a little bit, but it shouldn't take too terribly long. I'm probably going to want to get one piece of firewood going and then put more in there. But we'll see. It is at least warm in here, although I wouldn't call it hot exactly. Got a ways to go before this is a proper roaring Vermont fire. Like if I can hold my hand in here, that tells you something about how not hot everything is. Maybe it would have been a good idea for me to include kindling. But this is kind of kindling-like. It's not very heavy. See how it goes. And bit by bit, we'll get this going again. And we'll get the plug-in coding going again. Oh, but right now was not my moment for that, because it just went out. What else can we use here? I swear I might want to stack these back up with kindling in there. Let's see whether running a breeze of air from the center front of the stove into things will help it catch. I think it probably is. I think that probably is helping it. We might be off to the races, as they say. Whoever they is, it's not going to be me because I don't go to races. Yeah. I think that's starting. So let me go back up to the, I would say main computer, except for it's the streaming computer, and there's also the antique laptop that I do the actual coding on. So let me go back over to where I can see chat. How about? Well, that's the thing, is I'm Chris from Airwindows. I'm doing this in Vermont, and last week it was unbelievably cold. Now it's just very cold. And I get to say, hello. We're going to switch this over to Coding Stream and get rolling. So yeah. I think I did what I needed to for let's see, I think I might have some final details to add here, because a lot of work on Tuesday, don't mind me just sorting things, had to do with this. So I'm wondering whether I removed the unnecessary extra controls. Ooh, no, I did not. So after I finished streaming, I fiddled with this a little bit more. I added a cutoff and in and out gain volume smoothing. I could actually go beyond that a little bit if I feel full of beans today, because there were a couple of more things that I could smooth. If I remember correctly, this plugin has like a split done by the Bezier filter. If you don't know what a Bezier filter is, that's understandable because I basically invented it, and the reason it took me to invent it is because it doesn't actually work very well as a filter. But then I ran into a bug, and I have found what the bug is, and will be doing some things towards fixing it today. But this one, Z-acid low pass, leaves the bug the way it is because it made a cool noise. And let's see, I think I updated my names. Over, under, and meltdown. I don't think I need to smooth meltdown, but I could. This is technically C++, but basically everything that I do is basically programmed in C. So although it's technically a C++ framework, I'm only using C functionality in it. So let's see. I've got a cutoff, drive, and output. If I add 3 more smooth parameters, everything will be smoothed, and that's probably desirable, given that this is functionally a weird synthesizer filter in which at least the cutoff control needs to be manipulated kind of on the fly. And the chances of this being taken on by other synth projects, maybe not that great, but I'm going to do it anyway. And you can always run a raw synth output into this as a standalone filter. Oh, we're going to have the acid sickness today, yes. So over, under, and meltdown. And it goes up to parameter F. So I needed to remove these. We're not using them. And I need to make some over, under, and meltdown controls. So up to param F. Very good. That means the number of parameters is 6. And now I need to do a little more of this. Over, under, and meltdown. So what this does is I've got parameters in here that you could just apply directly, like gain, for instance. In-trim and out-trim are basically the same as a gain control. And if you apply them directly, well, it reads the control values once a sample buffer. And the buffer is what you do when you're setting like latency in your DAW. So it's like 256 samples or 16 samples or 1024 samples, whatever it ends up being, so that you can apply the setting of that control. Catch is, if you were applying that setting and just using that for the entire buffer, it's going to move in like notches. It's going to jump from one position to the other for each sample. So what people do is a control smoothing. And the way I'm doing the control smoothings are basically a linear interpolation between the control points. So it'll, at each beginning of a new buffer, it'll start where the control previously let off and begin moving in a linear progression to where the new position of the control is. So if you snap it to a new position, there will be one buffer frame where it'll go to the new position and then stay there. And this is a pretty quick way to get to new settings. So I like doing it that way. I have had things like there are versions of Purest Gain where there's a control, like a fade control or whatever, set to basically work as 0 to 1, and which does much slower application of new values coming in. So that's like using a fader, and it's a smoothed fader, so it actually just gradually goes to the new position. Whereas what I'm doing here for a synth type plugin is within the realm of your latency, it will instantly go to the new position. And that's quicker as far as getting to the final result. And so over, under, and meltdown is what I'm going to try to remember. Finish this, and I'll show it to you briefly, and then we'll move on. Also, I'm definitely going to be wanting to make another cup of coffee, but I feel I am talking intelligibly and at a quick enough rate. I've been trying to get many things done. A lot of yesterday was just carrying firewood, which can be kind of grueling, but I got about half of my indoors back of the house firewood racks filled with logs, so that's not too bad. And then I have another half or so that I still need to go and do, but I don't get to do that today because it's a streaming day, so I'm going to have to do that tomorrow. But I should be able to do it. That one has slightly less in the way of space to pile firewood up, so it'll be a little bit easier. I was freaking out. I was trying to carry firewood, and like water from the roof was like dripping on my neck as I go in the porch, and it started snowing. Well, I had all the wood uncovered. I'm like, oh no, snow is coming. And I got a brief little window of carrying a little bit more firewood, enough to do about literally half, and then stopped and made dinner. Here's the AU way of defining a lot of these things. You know, many of these things, if they were all literally the same, I could just ignore this entire case statement, and no matter what it does, it would say, okay, so no matter what this is, out parameter info unit is always generic. No matter what it is, out parameter info min value is always 0. The reason I have a case statement in here asking what control we're on is simply to make it be more obvious when I need to change one of them. But this could be replaced with just only this and only this, except for it, if I expect to have different values, then that would be another story. So if I wanted to get particularly frisky with this, which I don't necessarily, but everything in this case statement, these could be moved outside because they are always the same. The only reason they're in the place that they are and are being repeated so much is because these are the things that are done for each parameter that comes in. So it's basically doing a switch statement, and this is the complete list of everything that gets done for each control that comes up. But you could move that entirely outside the range and then have these ones. This is the only part that actually changes. But there's no special reason to do it differently because I've been doing it this way for a really long time. And part of what's valuable about the work that I do is a heinous amount of consistency. Bacon Paul did Airwindows Consolidated and a VCV Rack plugin, and is actually working on a couple of more. I'm not sure when he's going to be finished with them, but he's working on a couple of developments of that. And the fact that everything is always the same helps him out. So I keep it always the same to help him out. My VST code uses stereo always because the examples I saw of VSTs, VST2s, were stereo plugins. And I never got any information on how you make like mono VSTs, or if you would do quadraphonic or 5.1 in audio units. And this is an example of this. I'll tell you more about this. Let me double check that I've got that right. Yep, that's cool. Also, I got a little work to do here. No biggie. Just 3 more parameters. I'd better remind myself what that was. Over, under, and meltdown is what it was. One of the problems with having the kind of brain that can think of new things is it can be all scattered and stuff, and I don't remember what I'm doing from one minute to the next, or I'll get really lost on following an idea where it needs to go. And then we'll struggle with some of this. Ooh, and that's... Hey, some of that stuff isn't actually correct. What's my over and under really going to be? And then meltdown. And that does actually mean I need to go... So what these are doing... these are starting out at the startup positions of what those controls would be. And those are set somewhere else. So when I scroll up, what you see here is like default value becomes default value param A. I think this is where I got the K stuff. See, we've got all this stuff like K audio unit parameter flag is writable. And those are basically enums. Those are something where in the program, it's an integer value or something along those lines. But it's been set earlier in code. So although it is a reference number, you get to refer to it with this word, whether it's kDefaultValue underscore param A or parameter flag is writable or is readable. And that's why I'm doing my reverbs with K in the beginning of those, is because I consider those to be like essentially a preset thing where you can send stuff into the reverb and it doesn't turn into a different space. It's essentially, this is a given space. Sounds that you put into this will sound like they are in this given space. And it's not so much changing the space to be something completely different. Although I did end up adding more controls to it later. So returning to this. When I go up here, I see that I have values in here. Cutoff starts at 0.5. Over is 0. Under is 1, meaning it's set up as a low pass to start off with. And meltdown is 0, which is kind of what I would have guessed it would be. What that means is that this stuff should really be matching these things. And it doesn't, but it's about to. We should have started off with... didn't mean that. 0.5 here. Then 0.0 here. And 1.0 here. That the default values are. Now the way that this also works is as we put new values in, which they'll start at these default values if you've never run the plugin before. If you've used the plugin before and it is saved in your DAW, it's probably going to be saved with a different set of values. What we do is we assign meltdown A or whatever, the A value, to the B value and then come up with a new B value based on what the control is set to, and that's how it tracks the new controls coming in and smooths them. So in this case, meltdown is a special effect I'm going to show you before too terribly long. And over and under is what is under the cutoff frequency, so that if you have that turned up all the way, that is a low pass filter. over is what is over the cutoff frequency. So if you have that turned up and under turned down, that is a high-pass filter. And you're basically manipulating what goes around the sides of a crossover. There's another thing I'm going to be working on later today, where there's two cutoffs, there's two crossovers, and then each of these values go from 0 to 2. So the middle of the control, it's like a graphic EQ flipped on its side, and straight down the middle means no boosts or cuts. And the way those things combine, if there's no boosts or cuts, it changes the sound not at all. That's even true for this one. This is super high resolution, perfect fidelity, even though it's a really messed up filter, if the over and under are exactly the same. So in this case, since it's more about making it be a synth filter rather than boosts and cuts, if you have over and under cranked up to 1, in that case, it will be giving you perfectly flat, no effect at all on the output. So that might end up having its own useful qualities going on. But yeah, so now we've instantiated these as their basic default values. Here we are with this, although we are calling it over filter. So what I can do is follow the same pattern. Like later, I'm creating a value called cutoff, and it's interpolating between cutoff A and cutoff B. And then we're making the new cutoff B, and the cutoff A is whatever the previous cutoff B was. These are all going to follow the same pattern. So I'll put a little space in there, and then we're going to start having it mimic the behavior. Meltdown is already mimicking the behavior. Overfilter and underfilter are not, but I can fix that. So edit all in scope, over, edit all in scope, under. Weirdly, I don't feel like I have this functionality in JetBrains Writer for working with my Godot stuff. Seems kind of weird. It seems like that would be good to have, but I haven't yet worked out how to do that. But this old version of Xcode does. So what we've done is gone in, and here's where we apply this stuff. We made an under, we made an over. Those are just amplitudes mixing these two things, mid and treble. The one that I'll be working on later today is 3 bands. So there'll be a mid, treble, and a bass. And so there'll be a Bez A and a Bez B, which are the crossover filters. Excuse me. So now we've got under and over, but we're not going to be wanting to do this. We're going to want to do this. Oh, not that. This. And then we're going to want to match this part of the routine. We shouldn't have to correct anything here, so. And here's how you set up the beginning of the buffer with the basic settings, and then we're going to go through to the end of the buffer with the final settings. See, if we're starting the buffer, we have gone through and got to the positions of where they previously were at. So now we're looking up new control positions and using those. And having done that, we've just got a little bit of additional update. Let's make sure that all of that is correct. Oh, one final thing. I ran into this bug on Tuesday we've already defined an over b. In fact, we're setting it to a value up here. Look at what I've done. I had to fix this on Tuesday because I missed this small mistake. So modern compilers do a better job of warning you about this. Actually, can you see what I have done wrong, which I'm about to fix? Because I need to throw another log on my fire. So exercise for the viewer. And I might as well move that over a bit. So exercise for the viewer. What am I about to do? You'll be able to see it in what I fixed on Tuesday. And here I go with finding a reasonably sized log and throwing it on the fire. Oh God, I didn't even have the, there's a damper in here that engages the catalyst. I didn't have that engaged. What that means is I'm going to need to throw another log in here sooner than I expect. Maybe I'll throw one in now. Keep all this going. Oop. The piece of wood fell back against the rock, but that's probably fine. This has rocks in it. I will engage the damper. Okay, so the thing that I missed the previous time was this. I changed the name to over B, but we've already defined one of those. What that does, and I did this on cutoff and then couldn't figure out why it was doing what it was doing, and then figured it out. I need to remove the declaration here. What we're doing is we're declaring a local version of over B, and then simply using that. And what it did, I had that going on in cutoff. Like, it looked like this. Because I'd declared these variables, and I'd run the program, and the program did in fact run. But at no point did I ever, like every time we enter into this, it's using the cutoff that it started out with. At no point do we ever feed any new information into cutoff A or cutoff B, so it remained stuck. And so what I had to do, now we're using the one we declared elsewhere, rather than declaring another one with the same name which is local to the function. A simple, silly problem, a simple mistake. But it did get me, and we even need to do that for Meltdown. And now that we've done this, the local versions are never actually instantiated, so now we don't actually have these variables at all. If I try to build the program, it'll go, there's no such variable, because it's expecting something like that. So instead, we jump into here. We'll even stack it up so it's the same sequence of controls as before. 1, 2, 3. And over, under, see, I like keeping these a very consistent pattern, which is weirdly completely the opposite from what coders would have you do. But I can't be bothered by that because coders are exactly the same people who are being like replaced by AI and stuff. So I'm going to do it the way that I like. And we just go through, and now we're referencing the variables we declared before. And we have to make this up here now because it didn't exist anywhere else. And that brings us very close to actually being ready to build this and run this. So there we are. Now we have a nice little collection of 6 little things, all of which are control smoothed. All the A and B's are referred to correctly. This immediately uses the smoothed function. This is all literally all of this fits on one screen. Like this is my dither to floating point that I do for 32-bit hosts. Not 32-bit memory bandwidth so much as 32-bit bus variable. Hey. Very cool, John Dobb. Bear in mind that if you did that using console H or console X2, you would have a very similar thing available. Because it's a fairly similar thing to TAPAC built into those, but then you also get an additional boost in there. So yeah, I can well believe that that would sound pretty good because it's a good match for a Steve Albini style sound. So yeah, there's the dither that is part of my template. This part is directly taken from Z output stage. I have a massive overboost in here. And then this is cute because this is literally and exactly the Bezier function that I got essentially from Wikipedia, but also from, oh God, Freya, the helpful Bezier visualization video that I discovered. Freya Homer, I think that's who it is. That just ended up being a simpler way of writing it out than she used on her video. So I ended up going with the Wikipedia version. And there is a bug in here that stops it from being the same kind of filter that I use for things. And I found what it is, and we're going to go through and fix that today. But the weird acidy noise that it creates is the bug. This should build. It did build. And this should be everything I need. So we don't actually even have to go back into here anymore. We're basically ready to do the VSD version, and I could put it out this coming weekend if I wanted. And you don't get to hear it directly, but you get to hear it over my speakers. So option drag means I want to copy it, and regular drag means I want it on my desktop. I don't know why I have Bezier Q2 here. I don't feel like I necessarily... No, maybe I fixed it. I know I didn't fix Bezier Cubed. Bezier Cubed is the way I left it. We duplicated it over and made Z acid low pass out of it. So that's where that's going to become more interesting. Let's see. I don't know why I'm cleaning it up. I'm cleaning that up, but then when I go and do more work on this, it's going to have a faintly different video. Because the HDMI is doing 1080p and the color ACD is actually 1440 by 900. So that's a little weird. It moves the position of all of this stuff just a tiny bit. No worries. So as for sounds, I was doing all of my taking time away from the screen to go and make a cup of coffee on the Wounded Skies, because that has very bright brights that I can filter. But then I was doing all of this stuff on this sound. Oh, hi, why are you not going through the speakers? What's that about? Did I not plug into the right place? There we go. Here's the raw synthesizer sound. And this is the plugin as you'll have it. So you take over away and we have a low pass. But notice how it sounds kind of resonant. That's the acidy thing I was talking about. And you notice somebody was asking, like, Ed Heap 399 was asking, what does meltdown mean? Meltdown means this. Notice how it's now quieter? Because we have filtered out all of the frequencies over this very low position. We're filtering out everything that is not subsonic. I could release this weekend, yes. Put a little work in on the day that I have to carry a bunch of more firewood. It's doable. Like, I could make this one happen. Meltdown does this. It makes the subsonic information go a little crazier. So here we have a thoroughly subsonic sound, but rather than making no sound, now it makes a sputtering noise. And drive and output are basically the same distortion in my Z filters, so we can do this. It'll sound cooler when you actually hear it direct. You're hearing it through my speakers. So meltdown takes away the higher frequencies. Boosting it gives you them back. Up. And that's actually the high pass. We can distort, see. So when I do this, it goes a little crazy. And then we can go back to not distorting it. So this has a strongly acidy sound because it acts like there's a lot of resonance. But there's an aspect to it which is completely different, and I can show that to you using a sine wave. But first, one more thing. You notice how meltdown at 0 means it's better behaved, whereas meltdown at 1, it's a lot busier? Well, use it as a high pass. And it cleans up when meltdown is turned up. Now it's a high pass acid filter. It can go up fairly high. It's not overwhelmingly, but it's fairly high. But if you turn meltdown all the way down, the opposite happens from when you were used to listening to under. At least I think that's what we get. Hang on. Let's distort it and hear what it sounds like with the distorted. Oh, here we go. Okay, this is what I was talking about. Yeah, so here's what changes. Meltdown turned all the way up on over is a little more well-behaved, but then when you turn meltdown all the way down, freaks out. It freaks out. And then we can take it away, but then we can also put it back. So that was deeply alarming. But you know what also is alarming is if you throw it on a drum kit. I'm pretty sure I know what's going to happen here. Same settings, high pass, meltdown is... We're going to put it to the more muted version now, and we're doing a lot of drive. Check this out. Actually, no, that was just full on. It's a little different. So now we've basically got just the Z output stage distortion. If you had both over and under turned up all the way, or whatever we're doing with all of this, this is over but cutoff is down to the subsonics. So it's going to be doing some stuff, but mostly this is undistorted until we slam it. And then that low frequency waver comes in. Should be able to make a difference going on here. And then we turn it meltdown. So yeah, the synths, I think it's a little more interesting on the synths, but it does still work in there, and I will try it in some vocals. Here we've got some vocals. Rise and Mean vocal is probably a better choice. It's from a track I did in like 2022 or something like that. Never really went anywhere, but I did end up with some voices out of it. So you want high pass or low pass? I think maybe a high pass is going to be better. But this is low pass. Only right for... Let's try the undistorted one first. Can we definitely get a ring modulating thing happening? That's absolutely fighting the note. You can't even hear the note. So if over turns back up to 1, No change. Let's go to under now. Okay, you hear more of it this way because we're not filtering everything out but the resonant frequency. This is a voice, so it's got a lot of information. Mind you, I can try that meltdown trick. See, when we turn it up, it gets a little freakier. But the high-pass version freaked out when meltdown was lower. So this is cleaner with the high pass. And it's reacting a little differently. Yeah, not sure if I love that as much for it being disruptive. What then do you have to say? Only rightful governor of your affairs. This amounts to downright spiteful. Who's the fool who stands? Basically, we just have a nasty overtone. But if we do the opposite, we can completely replace the sound with the nasty. Or, yeah, see, there we're getting this sort of deeply nasty. So the overtone, undertone, is interfering. Now I'm going to bring a little bit of over in. You could also get sort of a walkie-talkie thing in a horrible way. So I'm going to call that successful. That is reasonably successful. Z acid low pass, folks. You will get to play with that soon enough. Now I'm going to take a moment and rush off and make my final cup of coffee of the day because it is noon, and if I time this right, I get to actually fall asleep properly tonight rather than drinking coffee too late. Oh, I bet there's going to be a lot of people who enjoy that. Oh, there's one thing I could do before going and making my coffee, however. I'm going to show you something. Then I'll go and make my coffee. So check this out. There we have some nasty stuff being generated from a sine. But what is this? Turns out this is absolutely key to what was going on with the other plugin going wrong. And we've just made a plugin to optimize this for what it is. So everything is set basically to neutral now. In fact, I can... Now it's all at default settings except for the cutoff. And it does this noise. But what does that look like on the waveform? That is a clue to what I have to do to get the other version of it working properly. There's a vital part of this algorithm that I've had on all of my Bezier like compressors and the undersampling for reverbs and all of that kind of stuff, which I don't have here. And you will see it thus. Look at that. That's what this algorithm is doing. It is doing the little Bezier curve and interpolating between these points up to and including, see the little hair on the end of some of these? That is not actually a spike. That is twisted wave rendering this accurately for a Gibb effect overshoot on a super fast transition between things. See, little spike, but then if we zoom in, we see it's a little bit of a spike there. Actually, that's quite interesting. I was expecting that I was going to see a swoop up and then a sharp line, but it's not quite a sharp line, is it? Those are actually samples modulating, so that's somewhat unexpected. I'm not exactly sure what's causing that, but the basic concept of it is still in place. So the way this algorithm normally is supposed to work is it's supposed to go do this one and then start at this point to continue the waveform over. And then it would start at this point to do the next step, and it would start at this point to do this phase. And I've omitted that. And that's what's causing the acidy sound. We got an acidy sound, which is able to throw, like, it's generating, like, it's forming sawtooths that modulate between positive sawtooths and negative sawtooths out of just a sine wave. And it's doing it all by doing the Bezier curve, but then not starting it at the correct point each time. It's supposed to be going around this curve and then start this one at that point, so it's a smooth transition between those 2 points. Now, if I go and see, we undo that, and then we load up the previous one, which I think I got fixed up. Yeah, BeziQ. See, we can barely even hear the lows now. So we'll turn that up, and then we'll kill the output of these. And then we'll make the cutoff go lower so that we see something else. So these are just sine waves, so I'm essentially attenuating them by doing this. I'm not hearing anything, so what we should see on this waveform, it turned into a weird modulating bass frequency. So that's not even remotely what we wanted, but it is at least, we are filtering what starts as a low frequency sound, and then we're getting nothing but a modulating DC value. We've converted it into a DC value. I'm going to say let's take that back away again and let me play with it a little more. So that's just a DC modulation. Again, this is BeziQ. This is not a normal filter, not by any stretch of the imagination. We've already heard what it sounds like in certain things, but this is what it acts and sounds like and does on a different kind of frequency. And here we are. At a low frequency, we still have sines here. Then as we start stepping upwards, it starts getting a little weird, to the point where now we have the Bezier filter doing its sort of funny modulation thing that it does. And so we've turned it basically into multiple sine-like shapes in which this one is bigger than the low part is a slower sine than the top part. We've basically changed the way this moves. Like, see, we've got the sort of triangle-y thing. It's leaning that away, and then it's leaning this away. I wonder if I can make that be fixed. Trying to do it so that it lines up nicely. Not quite working. If I can get this to do what I want, you'll see. Okay, let's keep fooling with it. If I can line these up just right, it'll appear to be fixed frequency when I scroll it. That's not going great, but I know what I'm trying to do here. See, they're like stacking up, and then they're not going right. It's going to be kind of fussy. Boy, what do I got to do to get this to do what I want? I'm stumped. How about this? No? How about this? If I get it even close, we're going to run with that. I'm wasting time. I don't love this. I want it to do a thing. Why won't it do the thing? Well, there's a thing. Okay, maybe what I need to do is replicate the wrap perfectly. And if I can do that, it'll be close. If I can do it perfectly, see, it starts there and ends there. So if I can adjust that in some way, it doesn't matter how many times it loops, if it perfectly blends. I don't have it perfect, dang it. Okay, close enough. It looks like it's scooting from side to side, but I can't make it line up perfectly. So we have a repeating frequency. And you can see it looks a little bit like a modulating wave here. And here it's leaning to the right and then over to leaning to the left and then back again. Goes through various changes as it goes. And at this point in the wave, this is tighter, this is looser. And the sound is like this. Except it's not letting me select. So we do this. Do I have the auto extend to zero crossing? We do. So now we have a sine-based bass sound that's modulating a little bit. And that's because we're running it through this funky filter. And that's a normal sine. So the reason that is not making the snarly, hideous distortions of Z-acid low pass is because it's using those offsets I was telling you about. So I'm going to fire up something to play, and I'm going to go and make my cup of coffee 10 minutes after I was going to make it. And then we'll go from there. We'll set this on loop. Or maybe, can we duplicate those? Yep, we'll set these two on loop. I'm going to throw another log on the fire, go and make my coffee, and I will be back, and we'll see exactly what I did with that one that caused it to not make the horrifying ripping noise. phosphorus. Yeah, oh, I bet it is, yeah. Here, I can change that. If we go to this view, it doesn't sound as good, but it won't shake your desk as much. I'm going to put this one back. almost there. Coffee is almost done. This track I called Dawn, and it's one of a series of tracks that are basically times of day. The album was called Full Day. It was before DAWs. It's done entirely using a computer sending MIDI messages to a bunch of synthesizers. Trying to think of which ones. There was a Kawaii G Mega and Kawaii K4R or something. I don't remember all the details, but they're basically Romplers. So that ought to do. But these sounds are largely, or a bunch of these sounds, are like manipulating Romplers in weird ways. So some of them, you're supposed to be able to make those noises. Other ones you're not. In particular, one of the tracks in there had an aggressive, gritty digital noise, and that noise was a General MIDI telephone sound effect, where the synth, a Kawaii G Mega, allowed you to turn on the frequency sensitivity of the sound, and then use things like modulation wheel or whatever to crank up the playback of the telephone sound effect until it went into wild aliasing and crazy behavior, at which point it turned into completely another thing. So, when I say you can do this, there's all kinds of things you can do. Even if you don't have a DAW, or even if you don't have plugins, what you can do is take regular synths and twist them into weird forms, do weird things with them. Speaking of doing weird things, I showed you those bass frequencies. I'm pretty sure BezEQ looks the way it does because I'm done. Yep, there we go. So we've got that. We've also got the other one to match it. But here's the bit that's important. The original version of BezEQ does this. Now, the thing that I'm wondering about, and we did some neat things with this last time I left off, I was putting delays in so that it could isolate stuff better. I also wonder whether I can incorporate some of the improvements, because there's a detail with this derez stuff that's not consistent with what I do in modern reverb plugins. And I'll see what it is if I go to the modern reverb plugins and look it up. So Mac AU, either of the recent ones will have it. K-Station or K-Woodroom, they'll both have it. So we're going to scooch this over this way because it's not the primary one I want to be looking at, but it will show me some of the details. And these details have to do with, essentially, am I repeating the final position on the Bezier curve, or am I transitioning between them in such a way that the final position doesn't occur twice? And that should have an effect on the sound of this plugin. So here's what we do with the modern ones. Here's the reverb, Bez cycle, Bez F, and so on and so forth. You can't see it, so let me move it over so that you can. So we're setting up a derez, just like we are with the one we're working on today. Pretty sure it has just only the one derez because, well, actually, no, maybe I have that in the... Yeah, we have a filter in here as well. So maybe the filter is going to be a closer map to what I'm actually trying to do. Because that's the same as the plugin I'm working on today. The filter inside this reverb is the same as the plugin I'm working on today, except for I'll have two filters, and we're keeping all of the bands between them. This makes it go both directions. This makes turning the filter part up from 50% do a sort of full frequency scrape that causes an overtone to come out. Whereas if you go left from the middle position, it's a stepped version of the roll-off with a smoother tone to it. That honestly might be what I'll want for, in fact, I'm not sure if I'm doing it. Here's the one we're working on now. This is a stepped version. What tells me it's doing that is I'm doing this. We're taking derez A, it's a unmodulated amount of going incrementally and wrapping around. And then I'm checking to make sure that it's not beyond the ranges, and then I'm dividing one by it, which is going to give me a exactly integer number of instances of this little loop before it starts doing another Bezier cycle again. More coffee. Got to get this one done. So here's where it says revised Bezier undersampling. Now here we get to do both. And I'm working out what actually I need to make of all this. Well, I see one thing very clearly. Drez freak and in fact we know that it's drez freak equals 1 divided by bez freak fraction. That is the same as where over here we're doing 1 divided by mid delay. And bez freak fraction, blah, 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 blah. And then we're sort of overriding it, aren't we? So we're declaring bez freak trim. And if we were using it, see, now the part that's confusing me is why is that an int? So you're going to just have to bear with me while I wrap my head around this. I think I can get the right results out of this. In fact, I'm pretty sure I can get the right results out of this because I'm basically looking at it. But I want to think my way through it in such a way that it's not losing me or throwing me. Like, this is, in fact, what it needs to be for the filter. And that's not to say that I won't end up having to revise this all over again when I start using cubic Bezier curves rather than quadratic Bezier curves. But both of the plugins that are open right now, are quadratic Bezier curves. And the reason that we are doing this is because the first instance of BezEQ had some bugs in it. And it's been out for long enough that anybody who's actually using it's going to want it to sound the same. So we have to do a BezEQ 2, which will do the same weird behavior, which I think is going to end up acting like extremely sharp cutoffs to the point of having a funny tonality to them, but in such a way that they can add up to perfect clarity. So it'll be basically a 3-band EQ with sweepable cutoff points, where you can have very, very sharp isolation. And it ought to work, but there is a final detail that might make all the difference in whether that sounds good or not. And that is, can I incorporate this frequency trim business? I know what this does. I'm trying to drink coffee and talk my way through it, both to, if anybody watches this in the future and needs help with it, but also so that I am on the same page as far as me knowing what I'm doing with it. So firstly, we know we're doing stepped frequency. BezEQ2 uses only stepped frequency. It doesn't use a sweepable one that's like continuous. It's only using the one where it's meant to sound smoother and not have ugly artifacts to it. Original BezEQ does have ugly artifacts to it, but that's because of the bug that we're fixing. And the bug that we're fixing is that each time we are instantiating the new Bezier curve and keeping a series of points to interpolate between, original BezEQ does not filter those at all. They're just sample points from the input sample stream, whereas it's meant to be stacking up a sort of average version and using those as sample points and then reconstructing from that, which is much better at doing a low-pass filter and cutting out high frequencies. Without it, we have kind of ugly, nasty overtones and funny things. And we're leaving Bez EQ out there because if anybody enjoyed what they were getting out of that, I'd be changing it. So this is the one that's supposed to do what Bez EQ was meant to do. Usually when I do something like that, when I put out a plugin where I have a fixed intention, I'm describing it in a certain way, and yet there's a bug that I did not catch, it's producing a strong, obvious tone, and it's not living up to my hopes for it. So what we're doing today, and what I'm talking my way around, hello Benito, is trying to fix up all of the bugs from what existed in Bez EQ so that it can live up to what I meant for it in the first place. And then we'll see what it sounds like. There ended up being a lot more to it than I even expected. Because not only did we need to do that additional smoothing of the input sample stream for making a Bezier reconstruction from a series of points, but we also needed to lay the dry samples to combine with them, which this might actually be making it a linear phase filter. I'm not absolutely certain. Because the thing is, it's not really a filter because the Bezier curve does not honor like harmonics or overtones or any audio related qualities at all. So if this turns out to be a performant linear phase filter, I would be the biggest and most surprised person in the world. But we're going to see what it does. We're getting closer and closer to what it does in the process of groveling through all of this nonsense. And again, if I went and asked AI to do this for me, it would be completely stumped because nobody does this. This is a graphics programming technique, not an audio programming technique. So there is no correct answer other than what I find of it. And that's why this is such a pain in the butt sometimes. Maybe what I want to do is just sort of vibe it in my own way. Going, okay, I see this part here, I see this part there. This worked before, this worked on the reverb. This is a filter inside the reverb. That also worked. So if I find the place where it says dres A equals 1 divided by mid delay, and then the same kind of code does a Bez frequency trim equals 1 minus what I just made times Bez frequency trim. And we're instantiating a new variable in doing that, by the way. And that makes me wonder why we've even done it in the first place. Why do I not just have that be Bez trim equals 0? Why do I not have it doing that? I'm overriding it each step of the way. So what am I talking about when I say that? Well, when you look over on Kwood Room there, what you see is that it says double Bez freq trim equals double Bez freq fraction, which is an int, divided by Bez freq fraction plus 1. Now that's a relevant observation. These are all doubles. And this is where we're leaving off. So when we have this, we need to develop this double freq trim thing in here. Why? Because it does this. In earlier reflections, here's the 6. Okay, that's interesting. Why are you doing that? Okay, there's the 6x6. Oh, are we filtering? after the end of the output? I bet we are. Yeah, look at that. See, it says hit the endpoint and we do a filter sample. We're basically filtering the output of the reverb, and then we're adding the early reflections, which did not get filtered. But we're not filtering the early reflections before feeding them into the reverb. We're filtering that afterwards. So that's fair. That is fine. But then here's where that Bez frequency trim enters in. We've got our Bezier filter thing happening in here again. In fact, we've got it set up so that it will do either form, either the stepped form or the continuous form. And then we've got double X. Double X replaces Bez F, Bez cycle. And that's where all this changes. What this is going to do is take this entire process, and I don't know whether I'm going to be able to adapt that to the cubic version. I'm not at all sure. Maybe it'll be very easy and simple, but maybe it won't. But this is the way that we do this, and this is why we do this. Essentially what this algorithm is doing, let's pretend we have a Bezier loop of like 5 samples. Well, no, 4 samples, because otherwise I'd have to stick my thumb up to be as tall. Oh, 8 samples. Hey, check it out, 8 samples. So we'll have 8 samples, and the Bezier loop goes around and incrementally works on like 1, 2, 3, 4, 5, 6, 7, 8, and then it cycles. The problem with this is that the way this system is set up, 1 and 8 are the same value. It's looping around so that if it goes beyond the final point, it's reset to the original point. What this means is if we have a evolving curve of some kind going on, we double count one of the samples we go through. And this is a problem because it introduces a funny little artifact. It's part of that sort of the digital hell sound that it produces, is we're taking that cycling thing, whatever the frequency is that it is, and we constantly introduce this little discontinuity because we're counting one of the samples twice. So what we have to do is exempt one of the samples and count only the 7, and then as we cycle through to the beginning again, rather than double counting it, we only count each of those positions once. And technically what we're doing in doing this with double X equals Bez F, Bez cycle times Bez freak trim is we still have our 8 counts, but now every single one of them is slightly rescaled. Like if this was a slope of increasing height, they'd all be a little bit less, so that when it wraps around to the first one again, it's smooth and continuous, rather than having both the first and the last samples being essentially the same value, which introduces a discontinuity. It's hell to explain all of this, but then it was hell to figure it out too. And I did manage to figure it out in such a way that I fixed the bug that it produced. Older reverbs that I make suffer from this bug, and so they have a slight discontinuity in them. So the whole purpose of Bez freak trim is to replace Bez F, Bez cycle, which cycles through until if it is larger than 1, it becomes equal to 1 again. And then we're scaling everything back by a certain amount. How much of an amount? It's up here. So there you have your deres freak, and then step freak true, and then we set it up until it makes a 1 to 0 value. And then we limit it. We're not doing, well, actually that isn't even true, is it? It's not inside over, or is it? I am no longer sure whether this is inside undersampling or not. If it's inside undersampling, it doesn't need to be further scaled. And then we are making Bez frequency fraction. I'm definitely puzzled as to why I'm going about doing this in the way that it is. But you know what? It'll be fine. I'll get through this and it'll be fine. Okay, I get it. I get it. I see why it does what it does. We're instantiating Bez freak trim. And Bez freak trim, see, this is what threw me. I didn't see what I was doing at first. And honestly, it's still a little bit boggling, but that's fine. If stepped freak deres freak equals 1 divided by Bez freak fraction. So we've already done this. Excuse me, sorry about that. We've already done this. We're doing deres A, and the mid delay equals 1 divided by deres A. That's going to be a larger, higher number. We're clamping it to no larger than 4096 because that is becoming our delay for the integer timing delay lines we've built into this plugin. Because this plugin has built-in delay lines so that it acts, I guess, more linear phase. Oh, God. I'm going to guzzle the very last of my coffee because this is like pulling teeth, man. But then it was like that on Tuesday as well. Tuesday was horrible and like pulling teeth, and yet I got the acid filter out of it, so. I'm just trying to keep up with what I've already successfully done before, without just blindly copying and pasting it. There, no more coffee. I'm banished from coffee for the day. This, however, is just water. So, Bez freak trim, Bez freak fraction. So int Bez freak fraction, that's going to be the same as int mid delay. Meaning we're doing stepped frequency. We're doing 1.0. We've already done that. But we still need to do this in 2 phases, and I'll tell you why. I say I'll tell you why, and then I immediately go, These are integers. These are the same. And let's take this to mid-trim. Mid-trim. There we are. So this needs to be a double. And we're making it be mid-delay minus mid-delay plus 1. That's going to give us the equivalent of a factor of, like if it's 4095, then it's 4095 divided by 4096. That gives us something that's almost, but not exactly 1. Or if it's 3, then it's 3 divided by 4. And that's going to give us, I'm going to grab the calculator and figure this shit out. 3 divided by 4. 0.75. Again, we're having things like 4096, 4095 divided by 4096 gives us 0.99999. So we have very close to 1 values. The smaller they get, the more we see out of this. But this is the fraction that gets taken away. Pretty sure that's accurate. But then we're doing 1 minus what we've got. We already had it, but now we're doing something else. So let's see what we get out of doing this, because it's stepped again. We'll do that again. And then where's dres freak? It's there. So it's dres A we're talking about. That ends up being 1 divided by our number, so that's a tiny little number again. That's what we're doing. So let's see. So now we've incorporated this as well. It's still losing me. I'm not going to lie, it's still losing me. I can see why it do what it do, but I can't follow why it do what it do. And that's annoying. But when we use it, and again, if it's not step freak, we are still doing a similar thing. We're doing it in an even weirder way. We're doing it 1 minus the power of dres freak times 0.5, comma, 1 divided by 0, blah, blah, blah. So that, like, I arrived at that somehow. I got this to do the job that it needed to do. I don't see, it's probably one of those things where I just started fooling with it and groping after a solution. And I don't know why that would be the solution. It seems really weird to me. But then maybe it's just really weird. Who am I to say maybe it's just really weird because it's really weird? Let's try duplicating this over. Because if that's what we need for that, weird or not, we're going to need to port it to here. That's the way that we get the amount of the difference between those 2 ints. That's where we use dres B, which again is 1 divided by a big int. So that's 1 divided by a big int, but now we're multiplying it by whatever this was. So that's probably going to put it back. So, okay. 1 divided by a big int gets us this, and then base trim, if we didn't add 1 to this, it would be base delay divided by base delay. That gives us literally exactly 1. So base trim is 1 minus this. This makes my brain cry. Let's see if it works. Even if it makes my brain cry, if it works, I will throw up my hands and concede defeat and enjoy the fact that it works. It'll get worse when I need to port it to the cubic Bezier polynomial. But that's a story for another day. While we're at it, let's change the spacing of these things. There. Now there's a midsection and there's a base section. So now we've got mid trim and base trim. And they're going to play a role similar to what we have at the bottom here. And yep, I didn't have to correct for it because it was inside the it was a filter and it was inside the undersampling, so that part's correct. So we're going to have this show up. We're going to replace everywhere it says Bez cycle and interpolates between these positions. We're going to replace that with X. And X is going to be defined on the fly by whatever it is we had up there. So let's see if we can make that work. We do have the capacity to define X. Here's where we do it. We're going to do one there. And I'm going to name these correctly on the fly. So this gets put to where these are every step of the way. Then, same thing here. We define X. Actually, we don't need to define it again, but we do need to use it again. See, we're defining these things here, but then we get to simply reuse it. And then we use Bez B, Bez cycle, and this time it's base trim. So in theory, when I update all of the things in these algorithms with X where the Bez cycle business would be, it will fix this. Now this is a slightly different number, but that's okay because that relates to what the reverb case of this is. It's not going to be affected by what we're doing with this stuff here. And then we'll see if it worked. Be interesting seeing if it worked because it was already behaving pretty well. But that faint little overtone, in theory, this fixes what that overtone did. And if it turns out that I have to build everything from ground zero because I can't incorporate this new upgrade to the new form of the filter, which I'm not even looking at yet, honestly. The new form of the filter is the one where I don't have this little piece incorporated. That which I have selected is the difference between the filter that sounds smooth and like a filter and the one that turns into the acid filter that generates all those little crossy waveforms. So, yeah. So the remaining part here is to swap out everywhere it says Bez cycle for X, everywhere it's used. And I can do that fairly straightforwardly. I am going to take a moment, however, to throw another log on my fire. Because we always got to throw logs on the fire. It's winter. It's going to be kind of fun when it's actually summer and we don't need to keep doing this all the time. But for now, this is the world in which we live. It's probably a nice variation from me talking into the microphone in circles and seemingly not knowing what I'm doing. And again, like I said, this is very much the kind of thing where I don't get to turn to like Claude or whatever and ask it for the answer, because it can't give me an answer. Nobody's done this thing before. Arguably, it's too dumb of a thing. Or I'll put it this way. If it gets to the point where the thing can talk its way through what it's doing, like I'm talking my way through what I'm doing, and that is what they call reasoning in LLMs, is they have to be able to talk their way through what they're doing. If it's able to do that with no actual correct answer out there to draw from, then that'll be something. I'm a little suspicious about that. I don't think that's going to work. Alrighty. Additional log acquired. Now, I got some Xing to do. X the first. Actually, I'll just click this. X the second. X the third. Again, these are all being scaled so that it wraps properly. There's another way I could go about doing it, actually, but I'm not worried about that right now. I could have it start wrapping at a different place. Honestly, that might be a good way to deal with the same problem as it exists with the cubic one. That might be a really good way of dealing with that. But this, I'm dealing with it the way that I did the previous ones. There. That should be the mid crossover corrected with mid trim. Now for the base crossover. Slow and write down so I don't select parentheses. I don't want to be selecting. And notice how this has an extra thing up in the front. That's going to be important later. Bada boom. We're interpolating between the 2 points on multiple axes. And this is how you make a quadratic Bezier. And then this is how I make it start from the previous position so it actually does it properly. And that should have done the thing. So now we get to find out, did it in fact do the thing? There's a couple of ways I can test this. First way is going to be just listening to some of the sounds. Well, this is easy to load. I can do that. So I should be able to filter that using this. Not that one, BezEQ2. Flat. And there should be no acidy overtone. There's just the faintest hit of an overtone, but that's not bad. I hear it, but I've heard it worse. Let's compare. So I'll use that, in fact. Back to default settings. Let's take treble and mid down all the way. So now we're filtering. This is the original Bezier Q. So that's cool, but that's not correct. I hear a lot going on. By contrast, the new version, and I don't know whether it's going to work if I do this. Let's find out. Well, it wants me to scroll this all the way up, but that's fine. So here's the same cutoff. That's definitely less mess. Here's her subs. What I'm hearing is a little bit of weirdness, but compared to the previous one, oh my God, it's completely a different scenario. It does feel like it's a pretty sharp cutoff. I'll be interested to see what that looks like, given that we get to do this. So I can probably see what this looks like fairly well, even though it's going to be ridiculous and bad. Oh, I can't select anything. I can't use the menu. Let's use the menu. There we go. So add the same effect that I had before. And with this, I should be able to see on like span. And span is not working well for me on this old computer, but it's okay. I'll use it anyway. Here's effect stack. Here's our filter. Let's move this over to underneath my camera and get it rolling. Okay. So that's cool. But what I should be able to do is see a very sharp cutoff. If this works the way I think it should be working, we get to see a pretty sharp cutoff on this. Now, how steep is that, though? Because it's pretty well working. It's essentially doing what I thought. Range low. Extremely massive range low. Arguably too massive. So here's my raw sound. What happens when we Bezier filter? Well, we've taken it down a bit anyhow. Let's change range again. So about 100 dB is usually what people consider audible. It can maybe go beyond that, but consistently audible is more like 80 even. Let's fool with it some more. .90 dB. let's adjust this to where it's right up at the top of the screen. How much does it pull off? And then let's raise the lowest frequency so we're mostly focusing on the bass note. Okay, there's our Zoxbox more or less sawtooth wave. In fact, we can, that's what it really is, so we're already doing stuff here. That's the raw capture. Engage B as EQ, and this cutoff is already engaged. In fact, looky there, we get to do a mid cut. So, okay, that's fairly, okay, so what is this point? Here's where we are falling off. Say we're at 600. It's bouncing around, being up around 30 dB down. What am I doing? So we lost a little bit of volume there. Tell you what, let's play with something else. Now we're flat. And indeed, it is perfectly flat. What happens if I play with our mid-range? Okay. We cut. How about we boost? It's certainly doing a thing. So what if we widen this out a lot? How much can we cut? There's our bass back again, and I don't think we can actually make treble not work. We can cut lower, but we can't really go high enough to make that matter. That's going to stay pretty much the same. So there's our maximal mid-range cut. We've certainly made these go flatter than they were, and they seem otherwise unaffected. See? Angled, much flatter. We can even make a notch. How big of a notch? This kind of notch. So we're notching lows by... That's definitely upwards of 30. We're notching those mids by about 10 dB or so. That's not too shabby. Well, you know what? We have other things that we can use to measure. They're not going to be in recent, but I can open them anywho. So let's go and find, not that, not that. What do I got to do in order to get this to work? Come on. Give me a break. Don't be making my life so damn difficult. Sounds. There we go. And a 96K noise. So this is going to be obnoxious enough. I'm going to turn the volume down. Although it's not blowing up the microphone that much either. There we are. That does look pretty flat, so slope is probably fine. Slope means we can do this with it. Oh, this is apparently default slope, huh? Alrighty, well then how about... close enough that it looks flat. Cool. Mid can do this. Alright, that's kind of on the low side. But this is 96K. We don't get to sweep it up to the point where... Actually, no, hang on a second. What are we doing? Seems to top out at about 10K. What I wonder is how steep of a boost that is. Okay, so on the white noise, we get to tell a little bit more clearly what's what. So here's our full blast. Lows are hovering at around 36 dB. Let me put that back. There we go. Then pump it up all the way. It doesn't sound that... It sounds more trebly than it reads. But the difference between the things... Okay, I bypassed the wrong thing. So that's hovering around minus 36 dB at its hottest peaks. And that's hovering around minus 48. So I'm only getting about 10 dB. It doesn't seem to care that much what this is doing. This is not as steep of a filter as I thought it was going to be. Let's find out what it does with some other situations. Flat again. Let's cut the highs. Okay, now we're getting somewhere. So some of my stuff did this when I was not summing correctly. I wasn't able to do really good isolation on the lows, but I was able to do really good trim on the highs. This is what we're taking out. This is as bright as we can get, which is basically, I'll buy that. It's doing its full cancellation of, like, see, 42, 36, thereabouts, down to 64. So that's a good amount of cutoff there at about 30K. So that's about half the sample rate. And then if we bring this in, that's doing a good job. I'm happy with the job that's doing. Look at how much roll-off we're getting. Everything's going away by a good solid 30 dB or more. And what's up here, I don't see any weird quirks happening. There's a little brightness there, yes, but I don't see any weird quirks happening. And then if we double it, now it's all very subsonic. So this is interesting. This is doing its job. I don't see any weird isolations. And we're running full blast white noise into this and not hearing an output. You can even turn it up. Lots. Here's what's left over. That sounds like white noise. I don't hear any weird overtones. Then if I bring this crossover up, that is crossing over base at a higher frequency. And I'm still kind of hearing highs in the white noise, but it does not sound like nasty digital overtones. It sounds like white noise. This looks promising. And then bring mids again. And then here's our crossover down to the mids. I do see a behavior here. Sometimes it's flatter. Sometimes this happens. Only at very specific settings, though. Also, can we stop that by manipulating this? Ooh, it made it go crackly. Yeah, no, that's the way it is. And then if we go over to the base crossover, we get to sort of double cancel it. Which makes the point of most cancellation kind of the most suppressed. So this is an interesting outcome. The thing I'm wondering about is what's up with this faint hiss. It's white noise, it's flat, but it's a faint hiss that I'm not really quite sure what to make of. Could it be that I need to amplify the volume of things by the same correcting factor that I used for X? Because the behavior we're seeing here is the behavior of tiny, tiny difference between things. Down to normal volume again. There's our blast of white noise. So it's acting like I'm passing through a perfect tiny amount of white noise rather than canceling it. And we're seeing it peak out. The amount that's showing through reminds me of the amount I'm dealing with in X, being that correcting factor that's getting produced. So I'm going to save this as one of the stacks I'm working with for debugging this stuff. Oop, we are all caps apparently. Although we did want a goodly number of caps here. We just need the EZ to be lowercase. There we are. It's starting out as flat, which is fine. I might be able to find better default values for these. And so here we are. We've got a pre-delay. We're applying the pre-delay. We're applying treble and mid-gain and treble gain are factors here. So what if while we're playing with this stuff up here, also note that I am not doing full cut. And the reason I'm not doing full cut is we're dividing by this somewhere. I think. Why are we not doing full cut? I've got it going from 005 to 2. That's what that does. Why would we not have treble gain go to 0? Because that would also explain why I'm not getting full cancellation. If it doesn't literally go to 0, then that would be why I'm seeing that. Why don't I get to turn that all the way to 0? Why have I got that fix in there? Ooh, I think I know why. Because I am doing this. And so I'm making them all match. That's why. Okay. So what would I do if I wanted to make this go, but I returned it to where there's a potential divided by 0? Because I know there's the potential divided by 0 because I see it. And the reason everything else has been corrected is so that they all match. I don't like that anymore, so I'm going to do it a different way. We're going to deal with that potential divided by 0 a different way. I'm now measuring it with like white noise and stuff against trying to make the output go to absolute silence because I want to see how well this thing performs. And we're getting close enough to where it might perform real well. So that's probably the amplitude of that correction. So time to go and find where we do this. And we're going to figure out what we need to do to get it to straighten its act out. Mid-L is our previously filtered thing, yeah? So, oh, okay, I think I see what's going on. So we only need to do that. At which point, if we turn mid all the way down to silence, treble will also go silent. And it'll be fine. Do I need to do this in multiple places? I think maybe I do. This is all about setting up the pre-delays. Pre-delays might also require some tweaking, but this is probably the thing I was observing. I like the sound of that anyhow. So right now, we're looking at the scenario of should I make this so that if you turn mid literally to 0, it also takes out high in the process? Is that explainable? Because I basically need to I can work, well, can I work around that? I don't know if I can work around that. I can. Here's what you do. We can include both of those, except for if mid-gain is literally at 0, we're going to be swapping in treble for it. Including this part here. And then if we do that, mid-L gets to have its combination of mid-gain and also treble gain gets turned up and down again so that it still stays what it's supposed to be. But if we literally did not have any mid-gain at all, well then we're going to not have it be this. We're going to have it be mid-L is now treble L. And that will do everything exactly the way you'd want. Assuming a treble gain is a real thing. Yes, it is. I just looked up and saw that it was. So mid either represents mid or we just make mid be treble instead and run the gain separately. That should do it. Oh, now what? What's your little problem? What's your little problem? Okay, it broke there. It broke there. Why did it break there? Oh. I'm disappointed. That should be fine. I shouldn't have to close that stuff in brackets. What the heck is its problem? This is a statement ending in a semicolon. This should be fine, and let me move on to the else. However, see, it was fine up there. This one up there is fine. Do we maybe not have a semicolon? Oh, see where the missing semicolon is? It's here. Now it's going to be fine. Now it was fine. Okay, I was looking in the wrong place entirely. That said, I am still going to put brackets in these things because a bunch of them are going to be stereo. Right now this is a mono, which in AU terms is N to N. And N to N means that you get to run it on like quad or surround or whatever. It'll work on all of those things. Back to our noise, back to our effect stack. Now what are we looking at? Cancellation. Ooh, okay, that's impressive. we've got lobes poking up here, but all the same, that's better cancellation than it was before. It's a little bit peaking up around 84, but mostly we've got one hell of a serious brick wall. That is a very serious brick wall. It's a bit of a lobe there, but will you look at that? Holy crap. Ooh, although it's a little funny that way though. When you get into the really deep cut. Okay, before you do the really deep cut, it doesn't act as weird. I can cut 78 frickin' dB off of the, well, 30 or so dB off of that. And it behaves itself pretty freaking well. Pretty well indeed. So in this older program, if I hold down Option, I get to make tiny, tiny adjustments. See, it's what it says right there. So we can quite easily make the noise floor be 84 dB down. And that's some pretty good cancellation on white noise. See, that's fairly flat up at 10K. By 30K, we're 84 dB down. That's like a 40 dB per octave. That's impressive. It's a little bit irregular. But man, this is performant. And if we forgive that slight funniness there, see, and occasionally we have these funny little artifacts. They're still like 70 dB down, but these are quirks of the algorithm. Oh, I heard that. Okay, let's test that mid-cut. Here we're cutting treble, although most of the treble isn't going away. It is making a noise as I switch back and forth between them. There's a spike. That might be a good enough reason not to be doing that. Spike only happens when I'm actually switching. So if both of these are cut, doesn't pay a lot of attention to this, but they're definitely overlaying each other. So we can make it have that little irregularity, but then remove it with that little irregularity. Let's see how far down it cancels. Here we are. Back to default. Cut them highs. Yeah, so we have some funny nodes. And that's not unusual. I can see that being a thing. Oh, and odd one out. Odd one out where it doesn't fully cancel. So sometimes it hisses in a funny way and sometimes it does not. And then regardless of what that's doing, we can also bring in mid and we're, well, no, that's weird. That's weird. Oh, I bet I know why. It's because we're transitioning to treble but then making it be 0. So what happens if we do this? We're getting funny interactions from this. There's no question about that. There's our steep initial roll-off. And then we overlay our other roll-off. We keep having those funny behaviors, but they're very, very far down. Like 180 dB down, or indeed 150 dB down, is not going to give anybody any audible trouble. Can we still boost bass? Yep, that is absolutely some kind of combination of comb filters going on. And our cancellation is weird. Back to default. I don't like that. Here's what I'm going to do. I'm going to go and change it. And I'm going to simply make it so that, let's see, how many undos do I need to do in order to make this go away again? Put that back. And lose this. So what should happen is treble will be completely fine until we turn it all the way off, at which point treble will abruptly snap off. And I think that's the best I can do. In fact, I can even make it a little more forgiving by not taking it too close to what might be happening here with the loud noises and sparks. Is that maybe when I am only evaluating larger than 0, mid-gain can be a absurdly large amount. Or you divide by a tiny, tiny, nearly 0 number, it'll make treble gain become really big, and the differences between those might be enough to cause problems. So we're going to evaluate for tiny but not quite literal 0 again. And let's see where we get with that. And there'll just have to be a note. There will just have to be a note of, yeah, if you turn mids all the way to 0, then highs will go to. Kind of suck it up and deal, because I'm not going to have a way of doing it also another way. It was too tricky. Or I could just restore that, but then have it bridge over. Let's find out what we've got first. We might be fine, because it's a strange beast. The next thing to do is experiment with those delays. And I have an idea in mind as to what I might want to do. So our base is apparently cutting off around 2K. That doesn't seem right. That seems better. And our highs are cutting off at a reasonable place, honestly. Failing that, they're rolling up about 10K. We could call that normal. Okay, what would happen if the low frequency cutoff only went up yay much? Okay, I'm not noticing a change there. Okay, we could cut that off there. So that would mean X could go from 0 to 0.5, and that's where the base lies. Seems legit. And I think the idea was that highs got to cross over around there too. I'm tempted to fuss with this more. I'm feeling like my level of fussing needs to escalate. And I'm still thinking about the amount of delay that I'm putting in on a sample-by-sample basis in order to make these things line up perfectly. Bits of it are working really well. Bits of it are working well, bits of it are acting funny. And I need to take another break. Not a long one, but I need to throw another log on the fire, do a quick pit stop, and so I'm going to be doing that. I'll be right back. It's just sometimes this stuff is more grueling than other times because I'm grappling with stuff nobody else is doing. Partly because there's no good reason to do it. These are dumb things to be doing. It doesn't bother me that they're dumb things to be doing, but it does mean there's no help for it when I run into obstacles. So I got to just wing it through the obstacles. Back in a moment. I'm going to rinse out my coffee cup while I'm at it. Okay. That fanfare means I'm back. I got 2 hours before thawing out cheese for tacos and 3 hours before tacos and 10 minutes. And let's see what we can make happen. So the thing that's puzzling me now is, should I be adjusting the delays being added to this stuff to compensate for what I'm generating regarding the trims I had to put in to make it line up correctly rather than overlapping? Am I slightly out of sync? So here's one of the things that I can do. Let's see what happens. And delay. Screw it, I'm going to copy it. Do this, and we get to adjust the delay of the overlaying the thing with the thing by what used to be the base volume control. Now, one of the things that was happening is I'm canceling them out, so that could be a whole other story, but I can override that by making base gain be 0. And I'm also going to mid delay, mid delay. So what this is going to do is it is going to show me when I radically change the delays so that they're no longer doing anything, what happens. What are we going to hear? What are we going to see on the measurements? We're going to do it over the noise again. And we're going to see what happens to the little cancellations. We're going to see what happens to the comb filter stuff. My feeling is that those delays are being useful. I can test this by setting it base gain to 0. And maybe that's my best first shot. We'll have base gain default to 0, at which point it should be canceling itself out. It won't be, but it should be. And then we set it all the way to 1. We have now repurposed param e to an internal modification. Back into the breach with the old twisted wave and our noise. And our effect stack. There. So now this is what we had before. What happens to the lows when everything is set to neutral? Or indeed, I can pump this up a little bit to up here. And pump this up to up here. Do we get cancellation at some point? Okay, no delays now. I don't see much difference. Okay. We've set it low. We're supposed to be not hearing bass now because it's set to 0. I still hear about the same amount of bass no matter what I do. I also don't see any differences, and I also see that the frame rate is ground to like 0 again. So that's unfortunate. So that failed. Let's look at what it does as a low pass, because we're looking at what it does as a high pass, and the high pass is still failing. Our high pass no worky at the moment. And that's not that big of a problem necessarily, because it is doing tone shaping. But it's not necessarily doing tone shaping in a useful way. So now what do we got? Bass gain is 1. We're also going to see whether we lose all the frame rate over and over again. I hope not, but I'll do what I can if that's what it ends up being. Some of it can be done by ear, probably. Effect stacks. Are you going to fall over and die? Well, that's better. So now we're set flat. There's our bass crossover. Brighter. We're going to have it end up about here at its highest, and there at the neutral setting. What happens if we are not delaying that? Let's show more of the range. Oh, it's struggling now. Oh no, it came back. What happens? Didn't expect that. Seemingly nothing happens. It's at subsonic. Oh no, wait, it's not at subsonic. There's no delay. And now there's ultra delay. Okay, back to default. Treble. Full delay. Treble goes away. What happens to this then? Ah, something happened. Not as much as I would have liked, though. What's up with this? This is now governing the sample delays I'm putting in. I'm not seeing any change, and I don't like that. Okay, back to full blast. Mid-cut. Oh, you got that. Okay, default. Mid-cut. We'll take it as far down as I can get it. And now we fool with the delay. That changed the sound. Oh, that's changing the sound a lot. So I feel that's making the highs lean more into the mid-range. They're not cutting off as much as they did. That defeated the, well, no, it came back. So if I take it off the tiniest little amount, we've got a striking change in tonality. And then we can throw it off completely like this. But the difference between this and just off of it seems pretty significant. Let's roll it off lower. I'm game for making my experiment. Here's what we're going to do. Yeah, we finished Z acid low pass. Got all of that done. Ooh, and you got rained out? Oh well. Yeah, don't catch a cold. Okay, so here's where we're at. We can leave base gain at 1. Right now what I'm doing is just fooling with some little details in tonality. I want to do an A/B test between delaying by exactly the number of samples that I generate using this algorithm. I suppose I could try like literally half. And then firstly, I want to see what happens when I do a delay by the... Yeah, I do wonder whether half is an appropriate answer here. We're going to set up a little sort of three-way test here. Heck with this, I'm going to copy and paste. I'm fed up. Don't worry, I'll get through this. And then we're not using param E in here anymore. No. So this does nothing. So if we have it at 0, it does nothing. So middle setting like 0.5. we get to do this, which is namely, we're going to change each of these according to the amount of trim we make. So base delay times mid trim. No, base trim. That's an int. Now they are independently set up. And then we can also do a neat little trick where we can go base delay times 0.5 in case the correct amount of delaying we actually want is halfway. Or you know what, let's get even fancier. 0.25, 0.5, 0.75, 3 tests, not just 2. We'll check that out as well. So the base control of 0 gets you, we could also be using the treble control for this too. You know what? Let's, as I'm really interested in what cuts are like, and that might very well involve cutting bass and listening to what it does. On audio, not just white noise, but I am going to start with white noise. So we're now repurposing param A. Ta-da! Oh, so let's make a little more space there. Okay. Off we go. Yeah, I've got like 3 hours to go. Woof. Well, if I do this, then maybe I can get into the other one that I haven't even begun.